All right, so today I'm going to be attempting to do a lecture on chapter 8.1 of the chemistry book. Enough students in the classroom. We'll see how this turns out. We want to be able to cover this material so that you guys have something to do over the weekend that will help you prepare for the material we need to cover next week, since we did not have class Wednesday or Thursday this week. So let's see here. We're talking about molecular compounds. Molecular compounds are backwards. Try that. Hey. So molecular compounds is what we're talking about. You see here on the right some toy compounds. We have these circular pieces which are joined together by sticks. In a similar idea, these round objects could be called atoms, and we could connect them to other atoms by things called covalent bonds. And we produce a variety of products. Notice we have the two-membered one. We have one that has 4, but is a different shape than the other one that has 4. And so we can get many different things out of these, depending on what we put together. What kinds of atoms? Now we have pink and green and yellow here, as well as how we organize them within the molecule. Let's see here. Forward. Nope. Do it this way. Okay. So, molecules and molecular compounds is what we're going to talk about. First question is, how are the melting points and boiling points of molecular compounds different from those of ionic compounds? So this is molecular compounds versus ionic compounds in terms of the melting point and the boiling point. So, we will talk about that in a moment. Actually, let's go back and answer that question now. So, ionic compounds have very high melting points, so very high temperatures for ionic compounds, so very high temperatures. Molecular compounds have much lower temperatures, so let's just say one arrow here. So ionic compounds, it takes a lot of energy to melt them or boil them. Molecular compounds, it takes much less energy to melt them or boil them. And we'll explain why in a few moments. In nature, matter takes many forms, such as gases, right? Gases can be in very different forms. If we have helium and neon, they are monatomic. So monatomic. Mon is like mono, which is 1, and excuse me. Atomic is, well, atoms. So monatomic means 1 atom. Now, these are single atoms. The way these look kind of depends on the state of them, but these are one. Oh, that's not going to. I'm just going to erase that. There we go. One helium atom by itself, or one neon atom by itself. That's how they exist in the gas form. So if you have the helium that's in the air around us, as well as the neon that's in the air around us, is in the form of single atoms. Single atoms, both in the kind that we put into balloons as well as the kind that we put into neon lights. All right, so some compounds are so different from ionic compounds that attraction between ions fail to explain their bonding. So some are so different from ionic compounds that the attractions do not explain. They fail to explain their bonding. So these atoms are sharing electrons and are joined by what is called a covalent bond. Now, the bond that we talked about for ionic bonds ionic compounds was the ionic bond, right? We also talked about metallic bonds. Metallic bonds and ionic bonds were different. Ionic, we said these were opposite charges attracting. Okay? Metallic bonds were nuclei, the positive part of the atom, floating in a sea of electrons. And so the electrons were shared throughout all of the metal atoms within the substance. Ionic bond, the electrons were stolen by one ion, and the other ion lost the electrons, and they were attracted because of the charge. In covalent bond, we are sharing electrons. It's a different kind. So, a molecule, definition of a molecule, is a neutral group of atoms joined together by covalent bonds. So, example being oxygen molecules. Oxygen is not monatomic. It is not monatomic. It contains two atoms, two oxygen atoms connected together. Right. It is, it is what we call a diatomic molecule. Consists of two atoms. Oxygen molecule is a diatomic molecule. So, if I draw my two oxygens here, they're connected by some kind of bond, okay? Connects these two oxygen atoms together into a diatomic molecule, which is connected by a covalent bond. Now, if a compound is composed of molecules, it's called a molecular compound. Just as if we had ionic bonds, or sorry, if a compound was made of ions, it is also therefore a ionic compound. Now, examples of this are water and carbon. These are both molecules, so therefore water and carbon monoxide are both molecular compounds because they are built out of molecules. This is one molecule. We say molecules are a neutral group of atoms joined together by covalent bonds. So, in this case, we have water. It's neutral by it once it's built into this shape. It is neutral, and it's held together by sharing electrons, which is what we call a covalent bond. And carbon dioxide is once again a neutral, and by neutral we mean not charged. A neutral, a neutral compound, which is held together with covalent bonds. So therefore, it is also a molecular compound. All right. Molecular compounds tend to have relatively lower melting points and boiling points. So that's lower than ionic compounds. Tend to. Two examples of these. If you're talking about an ionic compound, table salt is a good example. A good example of a molecular compound is water. In table salt, we have this kind of a structure, where we have our positively charged ions and our negatively charged ions arranged in a lattice of sorts, okay? That is an array of sodium ions and chloride ions for sodium chloride. The formula unit is one Na and one Cl, and that keeps on repeating itself over and over again throughout this throughout the sample. This formula unit is the thing that keeps on repeating itself throughout the example, or throughout the sample. The formula for chemical formula is NaCl. Now, in the case of water, notice we have 3 atoms depicted, this little white one, that white one, and this red one. The red is the oxygen, the white ones are the hydrogens, okay? And these are connected by covalent bonds. The connection between the hydrogen and the oxygen is a covalent bond, and by extension, the connection between this oxygen and that hydrogen is also a covalent bond. Now, the chemical formula for this is H2O, so that's the chemical formula that we need to look at. So those are 2 examples of one example of ionic compound and an example of a molecular compound. The difference is that we have ionic bonds here in ionic compound. This is also usually charged atoms. Well, yeah, it has to be charged atoms. And in this case, we have a covalent bond, and the molecule is neutral. Okay, another example. Ethane. Ethane is a component of natural gas, like the stuff we use in stoves and that we occasionally use in chemistry lab to heat things up. It's a molecular compound. Okay, it is built out of 2 carbons and 6 hydrogens. So in this picture, if you look at it real quick, where do you see the carbons? That is correct. They are these black ones. There are 2 of them. Okay, and then the hydrogens are these light blue objects. Those are my hydrogens. Okay, this is a molecular compound. Once again, it is a neutral molecule that is held together by covalent bonds. So therefore, it is a molecular type of substance, and then it's a compound because it's built out of multiple different types of atoms. All right. Now, what information does a molecular formula provide? We will talk about this here in a bit. A molecular formula is the chemical formula of a molecular compound. So this is the formula that lists what it's made out of. A molecular formula shows how many, notice how many atoms of each element a molecule contains. So how many? The example of NH3, this says there is 1 nitrogen and there are 3 hydrogens. And then this little piece here at the end, the G, means that it's a gas. Okay, this is our molecular formula. It gives us the number of each atom. Sorry, let me say that actually the amount of the number of each element in the molecule. All right. So there are several other ways that we can draw this. Here's our molecular formula. We just talked about that. That's the number. The structural formula, what do you think that will do? The hint is here in the first word. It says structural, which means it'll tell you the structure or the way that things are connected. These will often be two-dimensional drawings where you will just basically show the connections between the atoms. So structural formula connection between, once again, notice there's 1 nitrogen, 3 hydrogens. So we can also say that this includes the number. Let me make this more cleaner here. So this one shows the 2 things. First is connections between atoms. And the second thing is the number of each element present. Oops, fix that real quick here. Okay, so, and then this one is the number of each, that's a good way of putting it, atoms of each element present. Okay, if we look at the perspective drawing, this gives us perspective. So this is, and this is, the connections down here are two-dimensional connections. This gives us the three-dimensional perspective view of the structure. Okay? Second thing it does is show us the number of elements. All right, now, third one, ball and stick. This shows us a couple of things. This shows us the relative size of the atoms. And the second thing it shows us is kind of the three-dimensional shape, which is similar to what we see up here. So this should actually, a better way of writing this is not as perspective view, but 3D shape of the structure. All right, so let's see here, moving on. Here's some formulas of some molecular compounds. Here's the hydrogen atom. Its molecular formula, or its formula is H. Tells us there's one hydrogen that's involved. Example of carbon atom. Well, if there's a C, it means it's a carbon atom. If we have an oxygen atom, there's an O, and it means there's one oxygen atom. So, in the case of water, we have one molecule of H2O, right? One molecule. It contains two atoms of hydrogen and one atom of oxygen. Notice there's one red and two whites. Now, carbon dioxide, we have a carbon atom, right, the black one. There's one carbon atom and two red oxygens. And this is indicated in the formula by C with O with a subscript 2. So it is C, or 1C, and we omit the 1 that would be the subscript on that because it's redundant. And then we have 2 as a subscript on the O because there are two oxygens. So one molecule of CO2 contains two atoms of oxygen and one atom of carbon. So if we look at a slightly more complicated one, we have this ethanol that's over here. Notice its formula says C2H6O. So you notice in your drawing you have two carbons, the black ones, here and here. You have 6 hydrogens, 1, 2, 3, 4, 5, 6, and then you have an oxygen here in the middle, the red one. So that is one molecule of C2H6O gives you 6 atoms of hydrogen, 2 atoms of carbon, and 1 atom of oxygen. Right. So that's the general idea. Now let's talk about, I have a couple of quiz questions here. I want to show you an animation. First quiz section quiz. First quiz question is, compared to ionic compounds, molecular compounds tend to have relatively low melting points and high boiling points, low melting points and low boiling points, high melting points, high boiling points, or high melting points and low boiling points. Pick your answer. I'll give you about, pause the video here if you would like to take some time to figure this out. All right, so the answer is low melting points and low boiling points. Molecular compounds tend to have this. We will talk about why once we get farther into talking about molecular compounds. All right, so second question. A molecular compound usually consists of which of these four options? Two metal atoms and a non-metal atom, two non-metal atoms and a metal atom, two or more metal atoms, or two or more non-metal atoms. Choose your answer now. Pause if you'd like to have more time. Moving on. Two or more non-metal atoms is correct. If you look at your periodic table, and let me draw my ad hoc version here. If you have two, I'm going to use a different color too. Let's see here. Let's pick orange. If you do two objects from up here, two of them from up here, this is going to be covalent. If instead you pick one from here and one from here and put them together, this is going to be ionic. So this actually this whole section here. Let's use a different color here. Pen. The section over here, these are called the metals, right? That's where the metals are, both transition metals and alkaline earth and other types. And then the section on the right, over here, that is called the non-metals. There are the metalloids in kind of a diagonal, but we're going to, oh, right, so I should draw this in a different shape. It should be more like that. And the metals should actually be more along the lines of that. I think that's more accurate. So it does not include the metalloids primarily, but it includes everything to the right of that. And the metals include everything to the left of the metalloids. Now, third question. A molecular formula shows how many atoms of each element a molecule contains, a molecule structure, which atoms are bonded together, and how atoms are arranged in space. It shows how many there are of each molecule. The molecule structure is shown by the structural formula. Which atoms are bonded together? Oh, sorry. Structural is that one. A molecule structure was the. Let's go back and look real quick. Make sure we get the terminology on this right. Is the perspective drawing, and then the ball and stick. Actually, I guess there are two answers for that. Hold on. Oh dear. Go back. Okay, so structural. What is it doing? Okay, well. I think it just crashed. Let me see if I can troubleshoot it here. Something weird is going on. I don't know what it is. Well, in any case, apparently my PowerPoint just crashed on me. So the point is that on each type of formula, each type of depiction of the molecule has its own purpose. And you have to use the specific one you want for the topic that you're specifically considering. We usually use the molecular a lot, and then we'll use the other types to kind of gain more information once we understand the molecular formula. So that's chapter 8.1. I hope that helped. I'll talk to you guys later.